All right, so we are going to go over a couple of things today, but the first one we've kind of already done. So just to reiterate, when you are looking for, all we're doing today is we're putting the area problems that we've done onto the coordinate plane. So we're going to be doing area and perimeter problems on a coordinate plane, which if you looked at the chapter quiz review that we did, the ones with the colored tiles and the trapezoids and stuff, that's similar to what we're going to be doing today. So if it's on a coordinate plane, estimating irregular shapes in the coordinate plane works, in my mind, the same way as it does when it's not on a coordinate plane. You should still do what to find the area? Add up all the sides, or like count up all the little full squares, right? Again, this is not an exact science, so I don't want you guys to spend a ton of time trying to find exact things. However, another way you can do it is to split it up into different shapes and do it that way. So you can do it either way you want. Like, see how they split this one and they made it into a square? So then they found the area of that square. They split these into trapezoids and found the area of the trapezoids. But again, you can go ahead and just count them, and as long as your estimate is pretty close, then that's fine. Okay, so this is basically what I do every time. I just count the half squares and the full squares and put them together. I don't really do like quarter squares. You just kind of, like when Melanie was up here doing it, I was like, well, this one looks like almost a square. That's fine, okay? It's okay if it's almost a square. All right, so what happens if you have a shape on the coordinate plane and you're given 4 vertices, and the first thing this says is classify the polygon? What does it mean to classify something? Yes, exactly. Name the shape, give it a name, and how would you do that? The way we did this before is, how did you determine if something was like a rectangle or a rhombus? Sides. If it's a rectangle, the opposite sides should be parallel and equal. How do you know if lines are parallel on the coordinate plane? They have the same slope. Good. Okay, so if you're doing that, if I want to verify that it's a rectangle, we would just find the slopes of the sides to confirm that it's parallel, and then also confirm that they're congruent. But I want to focus today on finding the area and the perimeter of this shape. So unlike if this shape were standing straight up, so if I just gave you this right here, and I said, again, imagine that's perfect, and I said, find the area of this rectangle, what would you do? Yeah, length times width. So in this case, it would just be 4 times 2, which is 8. Okay, you could also count the boxes. All right. Now, I don't want to count boxes here. I want an exact area and perimeter of this. So what's different about this yellow shaded shape than the one that I just drew? It's not perfectly lined up in the coordinate plane. So what does that mean in terms of how you find the area and perimeter? You got to do more work. All right, what is that work? What do you mean? No, because we're not estimating here. So we need to find the actual area and perimeter. So what would we do then? I heard like 4 people say it under their breath. So one of you just say it louder. 1. Distance formula. Perfect. The distance formula. So you would need to find the distance formula, because to find area and perimeter, you need to know how long the sides are. So if we find the distance formula, do I need to do it for all 4 sides?
No. Yes.
Well, if I have one side in a rectangle, then do I need to figure out the other one, or is it the same? Should be the same. So don't spend more time on it than you have to. So you can do it this way. You can find the area by finding the length and the width. And then how would you find the perimeter? Once you have the length and the width, what would you do? Double them and then add them all together. Okay, so what do I need to find? What 2 legs? AB and BC, or AD and DC. Either of those are fine. We'll go with AB. And how do we find it? As in, what is the distance formula? Big square root. Good. Okay, x2 minus x1 squared and y2 minus y1. What's the coordinate of A?
-4, 1.
And what's the coordinate of B? 2, 4. Okay. And then what's the coordinate of C?
4, 0.
4, 0. And that's all we need in this case, okay? So we're going to do AB, and then we'll do BC, and then we should be ready to go. So AB, what is B? What is x2?
4.
That'd be y2. 2 minus
So plus
negative 4 squared plus
4 minus squared.
okay, what's 2 minus negative 4?
6.
6 squared is 36. What's 4 minus 1? 3 squared is, good. What's 36 plus 9? Square root of 45. All right, is that a perfect square? No. No, so we'll just leave it alone. We could also simplify the radical, which would be 3 root 5. All right, so I'm going to name this square root of 45, which means which other one is square root of 45?
BC.
Okay, and then BC.
2
What's 2 minus 4? Squared. What's 4 minus 0? Squared.
16.
So that's going to give me what?
20.
20. If I simplify it, it gives me 2 root 5. All right, so this is square root of 20. Okay, so now I just need to find the area and the perimeter. So for area, what would I do? Length times width. What's my length?
20, 40.
And what's my width? Okay, so you're doing square root of 45 times square root of 20. What are you doing for perimeter?
You're adding up all of them.
So 2 root 45, because I need 2 of those, plus 2 root 20. All of that you can do on your calculators.
30.
Okay, this is 30. Like flat, or is that rounded? Wow. Yes, 2 square root of 45 plus 2 root 20. What'd you get? 0.36. All right, 22.36. So again, you're probably going to get different decimals depending on where you round it or where you choose to, how you choose to put it into your calculator, but something close to this. Okay, so perimeter, what do?
You add them up.
Add them up, all the sides, and then area, what do?
You multiply it.
Okay, either way, what do you have to find first? The sides. To find the side lengths, you use the distance formula. Okay, so in a rectangle, you're going to do length times width. In a triangle, you would have to find the base and the height. Okay. All right, there's another way to do it. So imagine that we're looking at this polygon, and the black polygon is a what? It's a trapezoid. So we would need to find base 1 and base 2 and the height. Okay, so instead of doing that, what's drawn around the trapezoid? Maybe a square, maybe a rectangle. No, yeah, I think it's a rectangle because it looks like it's 7 by 8. All right, so does anybody have any idea what we could do if I draw that rectangle around it, Mariah? Find the area and then take away what shapes? Those triangles. Why is that easier? So what Mariah said is we can find the area of the rectangle and then we can take away the triangles, triangle A, B, C, and D. Why is this easier? It's still work, but it's easier because what do we not need now? We don't need to use the distance formula because all of these shapes are what? Like the base of these ones are what kind of lines? They're all straight lines. So we don't need to do the distance formula because you can just count the lines. And if you count the lines, then you can find the area mostly mentally. So So let's take a look first of all at the whole area. How tall is this rectangle? 7. And how long is it? 8. So the whole rectangle, what would the area be? 56. So then we just need to subtract from that A, B, C, and D. So take a look at A. A is a triangle. How high is it? 4. How long is it? Nope, it's a whole line, so 4, 5. So then what's 4 times 5? Divided by 2, which is 10. So this one's 10.
Wait, where are you going? Where are you stopping?
Right at the point?
Oh, okay. I thought you were stopping at the line. I'm looking. Am I
They
looking at?
label the triangles, not like the it's clear,
I see it.
Does that make more sense now? Sorry. I guess that's true. In my head, it's like, it's that one, right? So the triangles are what's labeled, all this stuff in here. Because this is 4 and this is 5. 4 times 5 is 20, and a triangle is base height divided by 2.
So you're gonna
Add them all together and subtract from 56. So then what's the base of B? 3, and what's the height? 3 times 2 is? Divided by 2 is? Good. Okay, what about C? 2 by 5. So that would be 5, because 2 times 5 is 10, divided by 2, or is 5. And then what about D? 3 by 6. 3 by 6, so that would be divided by 2 is? Okay. What is? Like right here? No. You don't even need whole squares. You're just looking for how long the line is. Because the fact that you divide by 2 covers the fact that this is half of it. Does that make sense? Okay. All right, so 9 plus 10 is? 19 plus 3 is? 22 plus 5 is? 27. So 56 minus 27. 29? Okay. So I'm not saying one is easier than the other or one is more work than the other. It's really up to you. The problem is if I just give you the trapezoid, you're going to have, if you want to do this method, which is totally fine, you're going to have to draw it. So then how would you do that? So let's go back to the rectangle problem we looked at originally. Let's look at this one. How would I draw that like rectangle around this rectangle? Essentially, you just have to draw straight lines to connect from one vertex to another. So if I want to go from A to D, where would I have to go from A? Down 4, and then over 2. So that would be like one triangle. So then what would I do to go from D to C? Go all the way over here, and then go up to C. All right, and then from B to C, over 2, and then down 4. All right? I do too. That's what I do. And like, I don't think the distance formula is hard, right? Like, it's just plugging stuff in. It's just, yeah, and it's not mental. So as soon as it's not mental, people are like, ugh, I don't want to do it, right? Which like is fine. I understand that. I'm in the same boat. So if you can visualize this, it will work for all the shapes like that we're going to talk about here. So if you can visualize this, that's fine. And then you just find the rectangle, find the triangles. Exactly. Yeah, so the height would be like from the lowest to the highest, and then the width would be like from the leftist to the rightest, the farthest left to the farthest right. Okay? And essentially what you're doing is the same thing you do when you find slope, right? To draw these triangles, you're basically saying, okay, I go up 3 and then over whatever. And then a lot of times when people draw a slope, they draw it like that, just draw it straight. But that's basically what you're doing. You're drawing those slope lines, and then that's going to be your area. So you should get the same thing that we got when we did I think it was 30, right? Which should be the same thing you got. What? 27? No, for this one. We did this one, it was 30, right? Yeah. Yes. When we found the area of this rectangle, it was 30. So I said, if you do it this way, you should get the same answer as 30. No, we didn't. That was a different problem. Okay. All right. Okay, so it's up to you whichever way you want to do it. For number one is an estimate. So if you're estimating, how do you do it?
You just count the boxes.
Yeah, you just count the boxes. Okay, so I would like you to do 1, 2, and 3, except for 2 and 3, just find the area. Don't worry about the perimeter. Okay? Because if you're just doing the area, then you then you can decide if you want to do the triangles or the distance formula. So do 1, 2, and 3, but just do the areas, not the perimeters. Yeah, for number 1, it's an estimate. So you're just counting the boxes inside.